Hello all, I'm Govinda Madhava, a graduate student pursuing Masters in Music Technology from Georgia Tech. At the Music Informatics Lab, I'm advised by Professor Alexander Lurch. Through this video, I want to take you through a project that is very close to my heart. Being an avid motorsport fan, specifically Formula One, over the last 18 months, I worked on this project, got to learn a lot of things, and I just want to share it with you all. To start the project, I was not able to find any data sets, so I created my own. This is a mega data set consisting of about 1100 hours of high quality engine audio data. This is the onboard engine. So this is what the drivers hear when they drive the race car. This is in wave audio format. And then I put together the telemetry for the corresponding audio. If I just share my screen here, for those of you who are not familiar with motorsports, this is how the onboard engine audio sounds like. So this is how the upshifts, the downshifts, and everything can be heard on board. And this is a sample telemetry data. Here you can clearly see that there are columns like race time, that is the timestamps, which is not uniform, very importantly. The lap number, there's the engine RPM showing what is the RPM of the engine at that particular time here. And then here we have the speed for that instant, the gear, the throttle, brake false as in not braking, true as in braking, and the tire compound the car is on. Okay, that's great. Now we have all of this. I have how the engine sounds at a particular time, and I have the numbers, the telemetry, the physics behind that sound. A few months ago, I did the basic task of predicting which team and track the sound could be. So if you provided an onboard engine audio snippet, it would my code would plot the pitch contours like this and then predict, hey, this is Williams. It says this Williams with a certain confidence. And then along with the driver, you have the track. So I was able to predict the track through leveraging the fact that in every track, the drivers use a specific set of upshifts and downshifts. So each track, there's a specific number of downshifts they do, the throttle duration they apply, the braking, etc., which you can clearly see in this. There's the downshifts and then there's an upshift as the pitch goes up. So great, the predicting part is done. But over the last 4 months, I went ahead advancing into the project. So I used pre-trained features like PASST, the past feature, and yes, let me just run this over the same audio that I have, made you listen a few minutes ago. Okay, great. This code is running. So what does this do? I'm trying to reconstruct the entire telemetry when a given audio is provided to the model. So here you just heard the sound of a Formula One car, but you don't know what the numbers might be, what is the speed that it's going through, and how do you determine what gear the car is in at a particular instant, etc. So using principles in audio signal processing and deep learning, I was able to develop this model which takes in an audio, and yeah, these are all the paths for the model I've already trained, and then it generates this test inference.csv in this case. Let's see what it says. So in this one, the model is trying to make a prediction every half a second. So you can see the timestamps going down. This is the engine RPM, okay, at 0.0. So in the same audio, I have used the same audio that you all listen to. So that is the race starting. So at instant 0.0, the car is at very high revs, when the race starts. There's a throttle percentage. It also tells you the gear. So initially the car was at 0, it was braking, and then it is accelerating, so it is false. So it tells you a series of all of these numbers that as humans we wouldn't be able to perceive just from the sound. So it shows you how the speed is increasing, the gears is increasing, the throttle, RPM, all of this, etc. Okay, great. So that's the first part of the project where I can reconstruct the entire telemetry using regression principles from the audio alone. For the second part, I developed this F1 dashboard. So, being a race fan, I wanted to see, hey, when a race is going on, what is the tire degradation that is going on? Which strategy is the best, and how do you compare the telemetries between the drivers? So, in the select track, you have a list of tracks, and here you have the corresponding teams and the drivers. You can filter all of them. For this case, let's consider the Albert Park circuit in Melbourne, Australia. So it shows you this dashboard shows you the previous results. This from 2024, the season that I have been working on. It gives you basic stats about the racetrack, the average time, and then the record. And here is a beautiful picture depicting the track. If we go to the second tab, here is the plot which shows you these are all the lap times. So each dot here corresponds to one particular lap, and you can see the numbers represent the lap time for that particular driver. You can filter by a particular team. For example, this is just the Ferrari team where each team has two drivers, so you can see the times here. Or you can close this and just see compare drivers too. That is possible too. So this is how it looks. And then the third tab is the more interesting part. There's the tire analysis. So it shows you the degradation. For example, the soft compound, which is known to have the highest grip around a circuit, it has the highest degradation, followed by medium, and then the hards, which are known to stay for a very long time. Here is a plot of the degradation. So you can see that the softs degrade very fast. It climbs up like a cliff, whereas the hard stays on for much longer. On the left, we have the time delta, that is the time lost compared to the previous lap. Here you can set, let's say you are a team manager or you want to be in the POV of one. And if you say, hey, let's set it to 2 seconds. So this tells you the optimal pit window. So if you do not want more than 2 seconds to be lost, it says that, hey, if you're on soft tires, lap 5 is the cutoff. Anything above that, above and beyond that, you will be losing more than 2 seconds per lap. And similarly, you can change the values here and make good sense of the graph here. Below you have the lap time consistency. We have all heard that great drivers like Sebastian Vettel, Max Verstappen, they have very consistent lap times. Here you can see the lap streak and the variations. For example, if you can sort all of these. So if I sort them by ascending, you can see that Esteban Ocon, who drives the Alpine Renault, he has a lap streak of 16 laps within a 0.5 second variation. So every lap in this window is within this time range, and he was on this compound of tires. And you can compare any of the streaks this way, sort them in any way you want. That shows you how consistent you need to be as a Formula One driver, hitting the same lap time each lap for a very long time. This is the telemetry and head-to-head pace comparison. So here we have two drivers, Alexander Albon driving the Williams and Carlos Sainz who was driving the Ferrari. Okay, so this is lap 1. You can change it to any lap you want. And hey, you have the results. So on lap 9, I have ensured that the lap times are normalized. So although the drivers start the laps at different times, they're not side by side, but using techniques in reading the CSV data analysis, I'm able to put them side by side and compare both of the laps. For example, here you can clearly see that the Ferrari is slightly faster, it is ahead in curve. So this is the speed versus the lap progression 0 to 100. This is the throttle. So in Formula 1, they're either at 100 or 0 most of the times. And here is the gear from 0 to 8 that you can see. If we consider some other laps, you can also see that the higher speed in Williams is slightly higher in the top speed corners from the Ferrari. This is typically the stuff that they show in the Formula 1 TV. So it is very cool to see that on your own in this dashboard. That is one thing I am proud of working on this. Finally, we have the strategy tab, where the team principals want to know when to pit, when not to pit. So this code analyzes all of the table. So here we have the summary table. These are the starting and the finishing positions sorted in this order. The gain column tells you the number of positions the driver either gained or lost. So here you can see that this particular row is highlighted because this has the highest positions gained, and this is the strategy they used: hard tires to the medium tires. And here it tells you the summary after analyzing all these results. It tells, hey, the soft to hard strategy, 2 cars used this. These are the average places gained, and this is the average pit window, which is the same as the tire analysis we saw. So it tells you the various strategies that were in play during the race, the number of cars that did this, and what is the expected results. Here it says that the top strategy for this particular race was soft to hard, and on an average 5 places were gained when pitting on lap 5. So this is a dashboard that completely tells you, analyzes the races for you, and you can